How's everybody doing? This is Mr. Bonhomme. About to do a little quick lesson on using number lines to solve addition and subtraction. Now, addition and subtraction, I've been telling the students they're related. They're inverse operations. But if you can do one, you can do the other. And most kids are more accustomed and used to doing addition. So, first, before we even use a number line, it's good to see how they're connected. Most times I have students, when they see a subtraction equation like that, to just set up an addition equation as well. This will start to make sense once more of it starts to develop. With addition, we have a part, and we're getting a whole. A part, and we are combining them, a part, and they make a whole, the entire thing, a total. And that's what we're trying to find, which is also called the sum in addition. In subtraction, the whole, which is the entire thing, is being reduced by the part, and then we're finding another part. Now, really quickly, I'm going to show a tape diagram, which shows this as well. And it kind of looks like this. This right here is a part. This right here is another part. And I'll use another color. When you combine them together, all right, the marker is a done deal. This should work. When you combine them together, this is the whole. So when you do not know the whole, you're combining the parts so then you can find the whole. If you know the whole in one part, you're trying to find the other part. That's why that makes sense, and that's why addition and subtraction are related. Now, to bring this over to the number line, let's do a subtraction equation. Let's say it's 21 minus 7, and you're trying to find that answer. 21 would be the whole, 7 would be a part, and we don't know this missing part. Let's just put the missing part as Z, just because. Now, these numbers will still go into this addition equation. We know that 7 is a part, 7. We know that Z is the other part. We don't know what Z is yet. That's the other part, Z. And then we know the whole is 21. 21. So I'll put that right here. The whole is 21. This is a good visual for kids to understand, all right, even if I'm not really skilled in subtraction, I could flip it to addition, and it will help me try to find that missing number. And also the tape diagram gives you another visual. To bring it to a number line, I'm going to draw my number line. And because most kids already are more effective with addition, I'm going to show it in that way. We will start at the part, and we need to get to the whole or the total. So this is 7, that's the part, 21 is the whole. And that's where I'm going to go at the end of my number line. Of course, I can add big numbers and big amounts. It's better to go to a friendly number, a 10, 100, and to go to those numbers and then build on until you get to the total or the whole. So what I would like to do is add 3. 7 plus 3, I'm doing that because it will get me to 10. Now, I'm at 10. I see I need to get to 21. I'm going to add a 10. 10 plus 10 equals 20. And now I'm going to go from 20 and just add a 1. I'm at 21. So this up here will let me know what that unknown part is, what z is. 3 plus 10 plus 1. 3 plus 10 is 13. 13 plus 1 is 14. That means that 21 minus 7 is 14. And that also means 7 plus 14 equals 21. Now this is with simple numbers. I'm going to make another video with some larger numbers. But this is just to understand the grasp. When they're adding or subtracting, especially subtracting, it's beneficial to flip it to an addition equation. This part-whole model, this tape diagram, is to also reinforce why this works. And the number line counting up, once you have it in an addition equation, is always good as well. So to count up from 7 all the way up to 21 and find the difference, the amount in between, and that's the other part. This is Mr. Bonhomme. Peace.